you should get the identity. Well, let's see how it works. Okay, there are many ways that we could slice this, many ways we could look at it. So the way we actually did it in class, I said, okay, A equals this, so I equals what matrix times A? Now, forget that I gave it away down there. In class, the first response I got was, well, okay, the I then is E1 times E2 up through E5 times A. Seems pretty obvious. We know it isn't right because we know that's the inverse down there. So, what's wrong with this? Well, if we write it out, we can see, and we need to understand how to simplify this type of a sequence of elementary matrices, okay? If we multiply this by this, then this times this would have to equal I, and it's not likely, okay? It's because matrix multiplication isn't commutative, okay? We know that E1 times E1 inverse is going to give us the identity, and E2 times E2 inverse is going to give us the identity, and each of those products is going to give us the identity, but when you write them out in this form, matrix multiplication isn't commutative. You can't change the order of any of these operations in order to get E1 over next to E1 inverse. And E1 has to be multiplied by E1 inverse, not by a bunch of other matrices times E1 inverse, in order to get the identity. So it doesn't work. Okay? So I say it's not likely that that's going to work because multiplication is not commutative. Now there are matrices that work both ways. If all your matrices were strictly diagonal matrices, then this would actually work because diagonal matrices are commutative. But nothing else is. Okay. So, or at least not your other elementary matrices is commutative. So what we have to do is write it in reverse order. Now that shouldn't surprise you because of what we've said previously, but notice formally when we write it out how that works. Okay, now E1 is next to E1 inverse. Now matrix multiplication is associative, doesn't matter in what order or how you group them, so I'm going to group this product with E1, E1 inverse, which are right next to each other in parentheses. Well, E1 times E1 inverse is just the identity. And if you multiply the identity times this is what you get, because the identity is the thing that doesn't change what you get. So that basically when you have an identity in the middle of a sequence of matrix operations, multiplications, you can remove it, because if you multiply it by the next matrix in the sequence, it's just going to give you the next matrix in the sequence. So it kind of disappears. Okay, then we have, get a white chalk here, because I've got a little smudge there. Okay, now we have E2 times E2 inverse, and that's not a symbol or anything, that's a smudge on the board. So we could group those. That's going to give us the identity. Well, the same thing's going to happen, and now we're just going to have E5, E4, E3 times E3 inverse, E4 inverse, E5 inverse. If we continue the process, each inverse matrix, or each matrix here, will end up next to its inverse, multiply out and give us I, so that ultimately we just get I. So that this matrix equation here, which should work, okay, because we want to get the matrix that gives us the identity. Actually, we want the matrix that's inverse to the A matrix. Will reduce down to I equals I. This is a true statement, so this must be a true statement. Okay, now remember that this is A. This thing in parentheses is just your A matrix. So the rest of this stuff has to be your identity. I don't know if there's a good way for me to notate that, because okay. I'm going to put a big yellow circle around this, and I'll do the same up here. So here's the A matrix. It's here, and of course we started out by writing it down up here. And so this matrix that we have here, since it's multiplied by A to get the identity, this has to be A inverse. So A inverse is the product, okay? E1, E2 to the left, E3 to the left, E4 to the left, E5 to the left. Okay? E5, E4, E3, E2, E1. And that's why the row reduction of the matrix, the A matrix, augmented by the identity matrix, reduces down to where we have the identity matrix. If you reduce it down to the identity matrix on the left, the matrix on the right is the identity matrix. Having gone through these transformations, okay? Now, the big thing you should see here is that any matrix that's reducible to the identity is a product of elementary matrices, okay? And those elementary matrices would be the inverses of the matrix you use to reduce it. These are the matrices you use to reduce A to the identity, okay? By this sequence. This is a sequence where we built A from the identity. Okay? And again, what did we do? We started with the identity, we applied this matrix, E5 inverse, then E4 inverse, and so forth. Okay? So, right there is A built up from the identity. This is A reduced to the identity. Okay? This matrix reduces it. And I can say that this product, since this sequence of matrices reduces A to the identity, has to be the inverse of the matrix A.